All right, guys, so welcome back. So now we move on to arteries. So it's important we talk about them one after the other. I don't want to make it a very long lecture. So it says here that the artery has some features that enables it to work efficiently. And what are those features? Number one, it has a thick layer of collagen and smooth muscle and elastic fiber. So this is what it looks like. This is the thick outer collagen, this part here. Then this is the thick muscle with elastin, which means it has ability to expand, Why am I saying this? Hear this, please. Every structure has its adaptive features that allows it to do its job. So basically here, this artery has this thickness, but a small lumen. Please don't mind the fact that the space here seems wide, but in reality, the space, the lumen within the artery is quite small, so that blood can move in high pressure, or let me say, for that reason, blood moves at high pressure in the artery. The wall is thick. The wall is thick. The lumen is quite narrow and it's elastic. So as blood moves through the artery, it expands. I'm going to show you that. In fact, you're going to know how we're able to get the, what's it called, pulse. So this elastic fiber allows the wall to expand around. So around blood surging through at high pressure when the heart contracts. So every time the heart contracts, the artery goes like that. Like it's not totally collapsed, but like it's like that. It gets bigger every now and then. I'm going to show you something to show you that right now. So this is why pulse can be taken on the heart through arteries. So check this out. Now, before I go there, good, it's here now. Now, this, please look at me wherever you're seeing this from anywhere. This is my, you can see this is my thumb. This bone is called, okay, let me do it this way. This bone is called radius, this is called ulna. So there's an artery here called radial artery. So if you put your thumb just gently over here, just see the way I did it, just gently over here, right? You can see it close to your thumb. Just like relax, just relax. You feel, boop, like the pulse of your heart will be felt. You might press a little harder if you're a bit fleshier than myself, like this. So now what are we doing? Yeah, you can also do it this way, either way, like putting your two thumbs like that, two fingers like that. Now check this out. So anytime the heart beats, the pressure is exerted on the wall of the arteries, and because it's elastic, it expands. You can see pressure within the artery, so it expands. So for that reason, you can feel the pulse. Now, man, this is not the only way you can feel the pulse on the artery anywhere, but because it's outward here and some other places in our body, you can feel the pulse really. So the point is, due to the elasticity of the wall of the artery, it expands. So for that reason, we can actually pick pulse like the rate at which your heart is beating per minute, so to say, or like the pressure exerted on the heart, exerted on the wall of the heart artery. Like that. So the point is, the pressure exerted on the elastic wall of the artery is being felt as the pulse. All right. This is something I want you to also try out, please. It's a practical class. It's something real. If you relax, you're going to feel the pulse there, and that's because of the elasticity of the wall of the arteries. And please, we only take pulse from arteries, not from veins, please. Now, it has a narrow lumen or hole for transporting blood. Now, because of the narrow lumen, blood moves in it at a high pressure. For this reason, it is called resistance vessel. Why? Because blood is forcing itself through it. So blood is moving quite forcibly. So we call it a resistance vessel. Resistance vessel. Not because blood will not pass through, but blood is passing through at high. Now it says it has no valve, except for pulmonary artery and aorta portion in the heart. Let me show you that real quick. Good. This is what leads to the aorta. This is the aorta like this. So this is a semilunar valve here. This is the valve that leads to the pulmonary artery. This is pulmonary artery, left and right. So these are not semilunar valve. So these are the only two arteries in the human body, and it is within the heart that it has this. The only arteries in the human body that has valve. Other arteries don't have valve. That's why I said it has no valve, except for aorta and primary portion in the heart. And that means that even when the aorta goes out itself, along its length, no valves. It's just the part within the heart. Now, all arteries carry blood away from the heart, no exception. All arteries will always carry blood away from the heart. Then arteries carry oxygenated blood except for pulmonary artery, which carries deoxygenated blood. So check this out here again. So you can see what I've done here. Pulmonary arteries are the only arteries that carry deoxygenated blood. So you can see this guy, this guy. Usually this is how I remember this thing, because sometimes students get confused with which one. How do I remember it? Just remember what arteries carry. They carry oxygenated blood. So when you put the word pulmonary, it's going to be the opposite of what others are carrying. For example, now veins carry deoxygenated blood. When you put pulmonary, it's opposite. So what we advise you to do is focus on what others are carrying. Arteries are carrying oxygenated blood, good. Veins are carrying deoxygenated blood, good. So once I put pulmonary, it's going to be the opposite to what others are carrying. I don't know if that made sense.